All right, so chapter 5 begins on page 220. And simply what we're doing, we've talked about sine, cosine, and tangent functions. And now we're going to talk about their graphs and what they look like. Because in calculus, and actually in a lot of math, the graphs for sine and cosine, especially sine and cosine, are called sinusoidal graphs, and they are good graphs to represent periodic, kind of regular repeating sort of situations. You'll notice a parabola, right, looks like this. And I was just talking to the Foundations 30 students about this yesterday. The shape of a parabola, right? It goes up and out forever, okay? But the shape of a sine graph is sort of has a part of it that looks like a parabola, part of it that looks sort of like a parabola, but it is repeating. This gets repeated over and over. And I'll show you kind of why that is. That's what this lesson is about. But this is a good representation for something that is repeating. So let's say, height versus time on a Ferris wheel. Let's say you're on a Ferris wheel, you get on the bottom, and you go up to the top, and then you come down to the bottom. And if you stretch that over time, it kind of looks like this. You go up to the top, and then down to the bottom, up to the top, to the bottom, this sort of shape. Talking about the height of a particle that's actually in a wave pool or on the ocean or something, that particle goes up and down as the waves go up and down. So if you graph that over time, it's up and down, so it looks kind of like this. So there's a lot of different applications, which means that it's a really important thing for us to study, and we use this as a model for different things in calculus as well. So, all right, so what we need to do is we need to consider our unit circle. Okay, that's where we're going to start, the unit circle. And let's just see what we can do from memory. Okay, so you guys just had a test on this last chapter where you would have studied this and used this extensively. So we have some important angles, right? We have kind of 3 important angles in the first quadrant. And those angles in radians are what? Theta equals this first one, pi over 6, good. This next one is pi over 4, and this next one is pi over 3, good. And in degrees, this is what? 30, 45, and 60, very good. Okay. We will throw in 90 degrees or pi over 2 here as well, and then 0, okay, just to kind of get us started. All right, so the cosine values, that's the first coordinate, right, for each of these. What's the cosine value here? For this one, the coordinate here would be 1, okay, and 1, 0. I guess we could do them both if you want. And over here, let's see if we can do this without looking at your book or at your notebook, see if we can remember. What's the length here? What's that number? Root 3 over 2, did you say? All right? Okay, and then what's this here? It's half, right? Okay. Now that's easy to remember for this one too, because they're the same numbers, just reversed, right? So this one is 1/2 and root 3 over 2. And this one over here, what are the coordinates here? Root 2 over 2 and root 2 over 2. Awesome. Okay, that's great. And this one is the coordinate 0, 1, right? All right, so that's a little bit crowded there, but those are important to know, and that's going to help us graph the sine and cosine function, and the tan later as well. But I think 5.1 is just sine and cosine. Okay. So what we're wanting to do is we're wanting to put this unit circle, which is a circle, and it's kind of a rotating, repeating sort of pattern that we've been working with. But what we want to do is I want to show you how this works as a graph. And so on a graph, we have kind of our x and y axes, except instead of x and y, we're going to make the x graph the theta, or the angles, okay, in radians. And we're going to make the y value, we're basically going to make, it's just going to be the values, I guess, the ratio values. So it's going to be, in this case, y equals sine theta value. We'll do sine first. Yeah. Okay. So y equals sine theta, and of course the x-axis is the theta. So what we're going to do is we're going to start at 0 here, and let's go to 90 first of all, okay? So 0 to 9, we're going to graph 2 pi in total, so if you want to do this, you can. 0, we're going to graph all the way to 2 pi, and so half of this is 1 pi, and half of this is pi over 2. So we're just going to graph this area right here first, okay? We're going to put our points on this area first. All right. So far, just to be clear, we've got the unit circle, and it tells us, what the sine and cosine functions are, or the ratios are, for each angle on the circle. And it's all the way from 0 to 2 pi is all on that chart. So we're going to start this by graphing theta as our independent variable, horizontal variable, and then the sine values, which are 0 for 0. For pi over 6, it's 1/2. For pi over 4, it's root 2 over 2. And for pi over 3, it's root 3 over 2. And pi over 2 is 1. Okay? So, it might be easier to... Actually, let's just look at this. What's the largest value we have here for a sine value? It goes from 0 all the way up to 1. Okay? So we're going to put 1 here, because we know we have to go from 0 all the way to 1. So put a 1 up there. And then we're simply going to map the coordinates. Here's the x, here's the y, right? So this first one is 0, 0. So we put a point at 0 theta and 0 for a value for sine. Good so far? The next one is pi over 6. Okay, well, it might be easier for you to envision this. Okay, here's pi over 4. That's halfway between 0 and pi over 2, right? That's pi over 4. Now, pi over 6 is 30 degrees, so it's not, this is 22.5. If you go half here, 22.5, so 30 degrees would be about here. And 60 degrees would be about there. What you want to envision is this split into exactly a third, or thirds, right? So it's 1/3, 2/3, 3/3 between those. So we're basically going to just try and do our best here. If you have, later when we're doing this exactly, if you have graph paper, you can maybe do this a little bit more exact. But for now, I just want to just give you the basic outline of how this is mapped. So this is pi over 6 here. This is pi over 3. Is everyone okay with that so far? Placing? So you see this spacing is roughly the same as this spacing here on the first quadrant, right? Okay. All right, so let's move up. Pi over 6 is 1/2 for a value. So pi over 6 is 1/2, and as careful as you can, put it at 1/2. And so that's our point. We don't know the points in between here yet, because on the unit circle, we aren't given the sine values of all of these angles, right? But we kind of can guess that it's a bit of a continuum, and you'll be able to see this a little more clearly. So pi over 4 is root 2 over 2. Now, this is in decimal right here. So what's root 2 over 2 in decimal form? Anybody know offhand? 0.707, something like that. Let's see if you're right. So square root of 2 divided by 2. 0.7071. Very good. So at pi over 4, we go up to 0.7071. So it's, maybe about here. Not quite 0.75. That'd be 0.75, so not quite there for pi over 4. Am I doing that right? 2 over 2. Yeah. Okay, so now root 3 over 2. What is root 3 over 2? Is a decimal? Anybody know offhand? Yeah, that's right. 0.86 something. So root 3 divided by 2 is 0.8660. So we go from here, and I'm going to put 0.8660. So right about there. And of course, we move along, and pi over 2, it has a sine value of 1. And that goes right up there at 1. So you're kind of seeing what's happening with these points right now, right? We're kind of looking like it's a bit of an arc, and I won't fill this in just yet, but if you chose an angle like 20 degrees or 10 degrees, something like that, and you checked out what the sine values were, you would find that they would fall between 0 and 0.5. So they would have points here, which we'll fill that in a bit later. But that's first quadrant, okay? That's first quadrant. Now, let's do the sine over here, second quadrant. We'll go a little bit more quickly here because, remember, these are all matched up, right? So we don't have to really think too hard. This would be, what is this for an angle? 2 pi over 3. And this is what? 3 pi over 4. Right? And what's this one? Sorry? 5 pi over 6, right? Okay. Okay, so those, you might not have those memorized yet, but you should be thinking about that, okay? So this is 120, 135, and 150. All right, so the values here for sine are going to be, what's the value for this one, 5 pi over 6? It matches up with this. So 1/2 is the value we're looking at. Is it going to be positive 1/2 or negative 1/2, do you think? Okay, I heard some negative, I heard some positive. Well, it's the y value, remember? So we've got a negative x here, but we have a positive y still in the second coordinate. So C-A-S-T, remember that? Sine is positive here. So let's do this 2 pi over 3. That's going to be root 3 over 2. Okay, does everyone see that? 2 pi over 3 is going to have a sine ratio that's similar, or the exact same to this one, root 3 over 2. So let's map these again right here, here, and here. I'm not sure if this is really tight for you or not, but because I know it's really small up here for me, but we'll do our best. Okay, so that's, I had trouble fitting those in, but that's those three angles there. So 2 pi over 3 has the root 3 over 2, which is that 0.8660. So that one's going to go right about there. Oops, as we move along, the 3/4 pi, or 3 pi over 4, matches to this value, which is the root 2 over 2. And so 3 pi over 4 is that 0.7071. Okay. Right? And then the 5 pi over 6 is 1/2. So 5 pi over 6 here is going to be this 1/2. So you see how it's symmetrical here? These are symmetrical. Those points are symmetrical, just like these values. This value is the same as pi over 3 and 2 pi over 3. And same here and here, here and here. Everyone see that? And then pi is, I'm sorry, where are we? Pi would be what? What's the coordinates for pi? Well, it's going to be -1 and what? 0. So you have a 0 here. So from the unit circle, we're able to map the points, or the values of the sine function, and how they're connected with the theta. Okay? So you've seen it before, and if you watched the video, you saw this. You can see this in your book. If we connect these points, because this is a continuous function, if we connect these points, we kind of have a graph that looks something like this, between 0 and pi. Okay. Any questions about that? Any problems with that so far? Okay. If we go around the unit circle, we keep going around, we're going to map the rest of it from pi to 2 pi now, and this will go, again, this will go kind of quick. If you have your unit circle, you can pull it out. I'm not sure if you want to look at that. And obviously you do see this in the book there as well. So on page 223, you can kind of follow along. So as you look at that and as you kind of do this with me, I think it'll make sense. So the next one, what's this next angle value here? Well, we'll be writing all these down here now, but what's this over here? Okay, so look at 5 pi over 6. Another 30 degrees is 6 pi over 6. That makes sense. So this is going to be 7 pi over 6. Okay, so let's put 7 pi over 6 there. And then this is a pi over 4, so that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and this is 5 pi over 4.